We're going to wait just a minute or so while people are signing on. So if you're already on, just bear with us for another minute. I'm watching the number of sign-ins, and we're just going to wait for another minute or so we can get everybody or most everybody in the room before we start. Okay, good afternoon, and thanks for joining us today. I'm Patricia Tennyson, the Executive Vice President for Katz and Associates, and I'm really pleased to be your moderator for the Orange County Water District's webinar, all about water reuse. We're still having some folks sign on, but we want to go ahead and get started because we've got a pretty packed day and some great speakers for you. I recently did the math and realized that I worked on a potable reuse project almost 30 years ago. So it's been a long and interesting journey that's impressed on me that it is always public or political opposition, never the technology, that has kept a potable reuse project from moving forward. I know that providing easy to understand information about the importance of a local drought-proof water supply is as important today as it ever has been. I remember way back in the day talking to a community member about the purity of the water from this process, and having that person had a puzzled look on their face and said, but won't this really pure water just get dirty again if you put it back into a reservoir? Well, direct potable reuse may help to answer that person's question. As many of you have heard those of us in the water industry say, there's one size does not fit all. We need a variety of approaches when it comes to effective water management. We have to consider all the options. We want a diversified water supply portfolio. The same could be said about water reuse strategies. It's exciting to be talking about where we've come from, about early IPR projects, and now about DPR draft regulations that are in the works. I'm really looking forward to learning more today from our speakers, Mehul Patel, Jennifer West, and Kevin Hardy, whom I will formally introduce shortly. I'm especially excited to moderate a very timely discussion on water reuse, as it supports much of what is driving the headlines and discussions in water today. Whether it's news about the looming drought, whether it's about the governor's drought package or President Biden's plans to invest in the nation's water and infrastructure and wastewater infrastructure, including water recycling. But before we begin, I want to do a few housekeeping items. As a webinar attendee, you are muted. That's to reduce background noise for everyone else. However, we do encourage you to ask questions of our speakers. Please type your question into the Q&A box, which you will see at the bottom of your screen. This webinar is being recorded and will be posted to OCWD's YouTube channel at OCWD Water News. You'll hear some introductory remarks from each of our speakers, and then we'll dive right into Q&A and discussion with this expert panel. So without further ado, I want to briefly introduce our speakers today. First, Mehul Patel is the Executive Director of Operations for the Orange County Water District, where he oversees district water treatment and groundwater recharge operations. He has been with OCWD for 25 years. Mehul's duties include oversight of the operations, maintenance, electrical, instrumentation, and distribution staff operation, responsible for the day-to-day operations of the 100 MGD groundwater replenishment system, the Green Acres non-potable reuse system, the groundwater recharge facilities, and the Prado wetlands facility. Mehul's expertise is in the use of advanced technologies for water reclamation and recycling. He has written, presented, and published numerous technical papers relating to the use of membrane and ultraviolet light technologies for wastewater reclamation. Jennifer West, since 2014, has been the Managing Director of Water Reuse California, where she has spearheaded numerous successful regulatory and legislative initiatives to promote water reuse in California. This includes sponsoring and passing AB 574, which directs the state to develop direct potable reuse regulations. She has also directed the development of the California Water Reuse Action Plan in 2019. Previously, Jennifer served as the Director for Water for the California Municipal Utilities Association, and was a contract legislative and regulatory advocate for numerous water districts and landowners in California. Kevin Hardy joined NWRI in 2017 as Executive Director. He works with policymakers and stakeholder groups to continue developing regulations for recycled drinking water and water treatment facilities. NWRI's well-established expert panel program helps guide technical innovation and policies that shape the future of recycled water use nationwide. Previously, Kevin was with the Encina Wastewater Authority, a public agency that provides recycled water and wastewater treatment facilities in San Diego County for 21 years, and was the general manager for the last 7 years of his tenure. We're going to begin today with Mehul, who will share some insight into OCWD's water reuse program, including the world-renowned groundwater replenishment system and how OCWD has successfully implemented the world's largest and most advanced water recycling program. Mehul, the floor is yours.
Thank you, Patsy. Good afternoon, everyone. Just want to give a little bit of background about OCWD's involvement in potable reuse, and a little background on us and some context as to why potable reuse has become a big part of our water supply portfolio and a big reason why we're able to continue in our function, which is to protect Orange County's groundwater basin. So the Orange County Water District itself is a special district formed in 1933 with the sole purpose of managing the Orange County groundwater basin, which is in the north and central portion of Orange County. And we also have to protect our rights to the Santa Ana River, which is one of our major sources of water for replenishing this groundwater aquifer. What makes us a little bit unique is that we are not a retail water agency. We do not distribute drinking waters to individual customers. Instead, it's our job to protect this groundwater basin, make sure it's reliable, make sure it's sustainable. And then that groundwater basin in turn supplies about 77% of the needs of 2.5 million customers in North and Central Orange County. So it's an important source of water for a large amount of people, and protecting it and making it sustainable is kind of our main job at Orange County Water District. Next slide, please. And so in order for us to maintain this groundwater basin and maintain the yield and its use for all 2.5 million people, we don't want to start with just one supply of water, rely upon one source of water. And you can see from this graph here that we've always had different sources of water, but in the past, we predominantly relied upon some local sources that were heavily influenced by natural precipitation. And then in particular, that would be our rights to the Santa Ana River. which we have rights to the river downstream of Prado Dam, the flood control structure here in Riverside County, and all the flows that come below it are the ones that we have rights to. So it's important that we manage that source of water, but that we in turn have determined would not be enough long-term due to ongoing drought cycles that we experience in Southern California and throughout the state and the arid Southwest, that we do get some natural recharge. But what we wanted to do was diversify our portfolio. You hear that a lot when you talk about investments, but it's the same for water resources. And so we've made a distinct contribution to look into and implement recycled water as part of our portfolio. And you can see in the latter years here, the blue bars being indicative of bringing groundwater replenishment system water into the mix of one of the sources for replenishing this groundwater aquifer. And then in years past, we've had our predecessor facility, Water Factory 21, from 1975 to about 2002, that was also providing some of the same purpose, but mainly for seawater intrusion. So we've made a commitment early on to try to diversify our water portfolio. And with the groundwater replenishment system, we've just basically increased that portion of our portfolio to kind of hedge ourselves against future uncertainty in both imported water sources that we were able to procure, and then the naturally occurring water sources that we have rights to, like the Santa Ana River and natural runoff and precipitation. Next slide, please. So the groundwater replenishment system itself, many of you may already know about it, but here's kind of the basic facts and how it fits into today's discussion. So the current facility produces 100 million gallons per day of ultra pure water that goes towards groundwater replenishment as well as seawater intrusion. So we would purify sewer water that would normally be used for ocean disposal from the Orange County Sanitation District, or OC-SAN. The goal of the project is to produce 103,000 acre feet of water a year, which is about enough for 850,000 people, given the usage in our service area. And it's been operational since 2008, originally at 70 million gallons per day, with the expansion in 2015 to our current 100 MGD capacity. And then what we call our final expansion, which is in progress now, about halfway through construction, to get the facility to 130 MGD by the year 2023. And at that current 100 MGD capacity, that's what makes us the largest potable reuse facility in the world. So operation, experience of operating this facility and some of the lessons learned gives a lot of context to how potable reuse can be done at a large scale. And a lot of the same principles that apply to our indirect potable reuse facility are going to apply to direct potable reuse. So there's some parallels there in our experience. Next slide, please. And so one of the things that went into our thinking into investing heavily into water reclamation and the use of recycled water and advanced water treatment technologies was we did have a predecessor facility, as I talked about, Water Factory 21. It was sized for 15 million gallons a day. It did provide enough flow to keep up with seawater intrusion barrier needs at the time. But towards the end of its life, we knew it wasn't going to be enough and we had to expand that facility. And in order to expand that facility, we knew we couldn't use the same conventional technology that was used in Water Factory 21. And so we made a commitment to look into new technologies, particularly membrane technology and ultraviolet light technology. But as part of that, we also decided to partner up. We were already partners with Water Factory 21, but more formalize a partnership with the Orange County Sanitation District because they needed peak storm flow relief. So they needed a place where they could discharge some of their secondary effluent besides their ocean outfall and put that water to beneficial use. So the synergy was there at the time. And then the big factor for us in terms of project viability was, could we produce a project that could produce water at costs that were comparable to imported water? Because we don't want to have one part of our portfolio where the water is so much more expensive than the rest that it ends up affecting our end users, our end customers, our retail water agencies that buy groundwater from us. And then funding was a big issue because anytime you use advanced technologies, the technology is expensive and there's a lot of capital costs up front, and paying back those capital costs are something that we had to take into account. And then at the time when we started, there were no formalized groundwater recharge regulations or IPR regulations. So we were relying on a kind of a framework of different legacy of regulations in Title 22 and interim operational regulations. And we wanted to know if that was something that we could overcome in a facility that was going to be much larger than Water Factory 21. So after doing extensive pilot testing, demonstration testing, we knew that we could have a viable technology that would replace Water Factory 21, still meet all potable reuse criteria at the time, and even drinking water criteria at the time. And then the main thing that we had to overcome, which was public perception, which many of you know is more important than even the technical components of the project, is to convince our public or our people in our service area that this project was safe and was necessary and economically responsible. And so we spent a lot of time trying to overcome negative public perception that had plagued other projects at the time that were considering a similar water reclamation projects. All right, next slide, please. So finally, I just wanted to kind of end it with one of the key components of the groundwater replenishment system, and one of the key reasons why it was able to be successful and in operation today is we had to have this successful partnership with the Orange County Sanitation District. So OC San has always been our partner, actually helped pay for half the capital costs of the original 70 MGD facility. We both have similar service areas, so both of us knew that in order to support this project, if we had to raise our rates, their wastewater collection rates, us, our groundwater costs, that we would be affecting the same general service area. So that was important. We're both serving the same set of people. Orange County Sanitation District as a partner has really stepped forward, not just with the capital contribution, but also the fact that they guarantee us a specification influence, meaning they give us a water quality of a certain type that we specify in this joint agreement, and that helps ensure that we can operate our facility at the cost that we plan for and make sure that the water quality that we produce is going to be what we need it to be without any variability. And then they agree to take back our residual streams, which is another important thing when you're using some of these advanced technologies, especially reverse osmosis, is having the ability to deal with those residual streams and deal with them cost effectively. And then we always had expansion built into the agreement, and we always agreed that any subsequent expansions, the water district would solely fund, but the sand district would support in the fact that they would have secondary effluent available as feed water to us, and that further decreases their need for ocean disposal. So any subsequent expansion, although owned and operated and paid for by the water district, definitely helps the Orange County Sanitation District in their day-to-day operations. And with that, I'd like to turn it back to you, Patsy.
Thank you very much, Mehul. Now we're going to hear from Jennifer West. Jennifer, can you tell us a little bit about how we got here, and also tell us where we are in terms of DPR regulations?
Yes, and thank you very much for having me. So as we look into the details of the new DPR regulations, I think it's really important not to lose sight of the bigger picture of why we're pursuing DPR. And it's because of climate change and drought and creating those sustainable water supplies. So potable reuse is a way to basically protect our future, our state's economy, and frankly, our way of life. And I just wanted to say that I'm very proud to be part of this effort with the members of the Water Reuse California, Orange County Water District, and all of our members. So first of all, the slide, I wanted to talk a little bit about how we did get here. We have on our path to DPR. So we basically made extraordinary progress since DPR began in earnest about 11 years ago. And this progress has basically been driven through legislative mandates and research, starting with the Pavli Bill in 2010, which was sponsored by Water Reuse California. So this bill required that an expert panel decide whether it was feasible to develop statewide DPR regulations that were protective of public health. Shortly after the Pavli Bill, Water Reuse California and the Water Reuse Research Foundation, now WRF, developed a DPR initiative, which raised close to $6 million for the needed research. And the next major step occurred with the final adoption of the groundwater regulations in 2014, which was also mandated by legislation. 2016, the Water Board released an expert panel finding that it was in fact feasible to develop DPR regulations, assuming the 6 priority research projects were complete. And so again, this was not a mandate, this was just a report. So Water Reuse California did not want this report to collect dust like so many other reports to the state do. And we sponsored AB 574 in 2017 with the California Coast Keepers. And this required, with some caveats, that the Water Board adopt DPR, adopt raw water augmentation regulations by 2023. And it also separately defined raw water augmentation and treated drinking water augmentation. And then after this, the final reservoir augmentations were adopted, which was also mandated by the Pavli Bill. 2019, the Water Board released its second framework document for regulating DPR. And earlier this year, the priority DPR research was complete. Finally, in late March of 2021, the draft DPR regulations were released for public comment, which I'll be discussing in a moment. But this has been the path to DPR. And while it has been driven, as I said, by legislative mandates and research, there's no way we could get this far without the tremendous leadership and political will at all levels, with Orange County Water District being a major trailblazer. And I also have to give credit to the Water Board itself for keeping us on that path with all the different activities that they have going. So let's turn to the DPR regulations in draft form as they are now. So first, the process as we understand it. All DPR regulation comments are due to the Water Board by June 25th. The Water Board's going to respond to these comments and decide if they want to make adjustment to the regulations, and we'll send out a second draft. At this point, there will be a peer review panel that will assess the comments to confirm that they conform with requirements, and the expert panel will then assess whether they are protective of public health. Now, we are hoping that the expert panel will be able to opine on some of the larger issues that I'm going to go into a moment. Water Reuse California has a DPR working group that's working right now to develop a comment letter. And I'm hoping that this draft letter will be available to our board and our legislative committee for review next week. So turning to the regulations themselves, here's just a very major overview of the big issues and concerns that we have. The draft basically makes no distinction between raw water augmentation and treated drinking water augmentation projects. They put them together, even though the legislation separately defined these two types of DPR, and the second framework document articulated different levels of risk. So these regulations basically treat placing purified water into very small reservoirs the same as purified water going directly into drinking water distribution systems. So we're asking DDW to consider offsetting some of the treatments, monitoring, and/or operational requirements to account for the benefits of the raw water augmentation that are less risky. For pathogen control requirements, the draft regulations require much higher than expected log removal reductions. So we're going to request that DDW work with the new DPR expert panel to identify the multiple layers of conservatism in the pathogen requirements and define the appropriate levels to achieve DDW's daily risk goal for both raw water augmentation and treated drinking water augmentation. Turning to chemical control requirements, the draft regs require ozone and biologically activated carbon, or BAC, to be included in the treatment train before RO. So for hybrid plants that want to perform groundwater augmentation primarily and then switch to DPR, this will mean that their groundwater augmentation water is basically subject to TWA level treatment. So we appreciate the inclusion in the regulation of an open-ended alternatives clause. This was in the groundwater and the surface water augmentation regulations as well. So, and we're asking DDW to explain in its statement of reasons the performance requirements for the BAC in 03. So basically we can prepare a research agenda that can be developed to find processes that could provide equivalent treatment and be placed at the end of the treatment train for these types of scenarios. There's also a requirement for online monitoring of the sewer shed. And this is a concern, as the industry has yet to demonstrate the feasibility and reliability of this approach. The regs also raise levels considerably for operators. The regulations require advanced water treatment operators certified at 5 to be on the site 24/7. So we're going to be recommending the requirements for on-site staffing at the facilities should be assessed on a case-by-case basis, but particularly at the drinking water and wastewater treatment plants where we don't believe the 24/7 on-site staffing may be necessary. So as I said, these are just big picture issues. There's going to be some more detail in our comments, but I wanted to give you all a flavor. And again, we would not have been here, and despite our issues with these regulations, we are very pleased that they have been put out, and we look very much forward to working with the Water Board and moving forward on the regulations. Thank you very much.
Thank you, Jennifer. Now, Kevin, NWRI recently released a remarkable tool for California utilities to use when considering DPR projects or future DPR regulations from the State Water Resources Control Board. Can you tell us a little bit more about that?
Yes, I'd be glad to, Patsy, and thanks again for having us and giving us an opportunity to talk a little bit about how DPR is progressing here in California. First, a little bit about NWRI, if you're not familiar, and I look out now to see over 200 participants, many of whom are members of the NWRI community, many of whom are not. Let me tell you a little bit about NWRI. Founded in 1991, it is today a joint powers agency and a 501c3 nonprofit. It was formed by a consortium of public entities and concerned citizens to do research, development, and implementation of water resources projects, including management of water resources, enhancing water quality or supply, encouraging water conservation, preventing or remediating degradation of water quality, protecting the beneficial uses of water resources, and improving public awareness and education with respect to those resources. Next slide. What we do. Oh, hey, we lost something there, but maybe, I don't know, something lost there, but well, let's talk, what is NWRI? NWRI is the nation's collaborative resource for the advancement of water resources science, policy, and innovation, and the independent expert advisory services provider of choice for the most challenging water quality, water resource management, and related innovation issues. What we really do is provide insight and understanding of current and future issues in water science and technology. And we do that through a lot of different techniques, including our independent advisory panel, the issuance of frameworks, for instance, the original DPR framework document that was published in 2015 in partnership with Water Reuse, AWWA, and the Water Environment Federation, and the work we did with water reuse on bioanalytical tools in 2019. So next slide. There we go, perfect. The guide that we've just recently released, Implementation of Direct Potable Reuse, a guide for California utilities, is one thing that we can all work on right now while these regulations remain kind of in this unknown status, to learn more and develop a deeper understanding of the scientific, the technical, and policy challenges, and there are many here. The effort was started back in December of 2016 by the Ventura Water Agency, and ultimately we were joined together with the Los Angeles Department of Water and Power, SFPUC, Valley Water, and the City of Santa Barbara. So this project was put together by Corolla and NWRI, and we had, if you advance to the next slide, you'll know that in our presentation to introduce this slide that it was really put together for utilities, for regulators, for consultants to think through these challenging projects from the very beginning. We know that these projects take, from our experience, these are 5 to 10 year minimum sorts of investments of time, energy, and resources. And these are very complicated projects. They should be hard. So starting right now to learn more about how these regs can impact your future planning is a good idea. Next slide. Always want to acknowledge the project team here, NWRI, myself, Suzanne Sharkey, Andy Salveson from Corolla, Adam Olivieri, who will be one of the co-chairs of the expert panel, Charles Bott from Hampton Roads Sanitation District, and Dan Garrity from the Southern Nevada Water Authority. In addition, I always want to thank the staff at Corolla for putting together this document. Really, the production value on it is amazing. There was extensive collaboration pulling this thing together, and the State Water Resources Control Board even participated. Next slide. If you came to our If you came to our release document party, if we go to the next slide, please. There we go. If you came to our release document, the release indicated, hey, we had 13 pieces to this to implement potable reuse projects, but we only covered 12. So I wanted to cover number 13. So if we'll slip to the next slide, we'll talk a little bit about the 13th area, which is collaboration to spur innovation. Next slide. So these are important public works projects, as we've talked about before. We're solving critical human and environmental health challenges. And there's a need now to embrace this one water framework that really includes a value for all types of waters and creates and builds upon our existing sustainability ecosystem to drive water supply and quality in the future. Next slide. In the context of DPR, there's a variety of opportunities for collaboration. Three that I think are often overlooked and I think will prove to be very challenging are the governance, the research and development that is required at the utility level to support these programs over an extended period of time. And of course, independent advisory panels, which are important to NWRI. Next slide, please. We think the use of expert panels is important to build public credibility and trust in these projects. As Mehul mentioned, we know that public acceptance is a critical aspect of these projects. But there are a lot of other opportunities for collaboration that we wanted to put forward in this report. And one of the things we're doing right today was talking about these kind of projects and what they mean. There are other opportunities to collaborate through WRF's tailored collaboration program, by joining water reuse and both the National Association and the California Water Reuse Chapter, being part of CASA, the California Association of Sanitation Agencies, or the Association of California Water Agencies, are all excellent opportunities for folks to collaborate and to find ways to deliver these really complicated projects. Next slide. So if you want to get a copy of the implementation guide, it's available for you. Just email Mary Collins here. We'd appreciate if you do that. I want to remind everybody, if you're thinking about fellowships through NWI, those applications are still available through the end of May. And to kind of bring this back to the next slide, and to bring this kind of back to the top, this is pretty much what my head's doing right now. And but I think go back to what Jennifer kind of centered us on, which is that public comments on the early draft of the regulations are due June 25th. And there's going to be a state mandated peer review panel, and our expert panel process and report are all required before regulations are due in December 2023. So we have quite a task ahead of us. I look forward to answering any questions that are out there. And once again, want to thank OCWD for this opportunity.
Thank you, Kevin. And I'd like to welcome back all of our panelists, Jennifer and Mehul, and let us now move into the question and discussion period. I'm waiting to see what question is first, but before we get that going, I am curious about whether IPR is still a viable process for utilities to consider, or should everybody be considering DPR?
I guess I can start with that one since that's all we do. Yeah, I mean, obviously IPR is still very viable. It's the one that has a mature set of regulations in place. It's what most of the projects that are either, you know, obviously the projects that are being planned, most of them are IPR projects. You know, there are certain circumstances that make IPR more advantageous, particularly if there's access to a large reservoir groundwater basin, where you don't have the ability to, or you have the ability to create an environmental buffer. You have a set of mature regulations that will allow you to do that. There's a little less risk in that. There's also the ability to kind of blend different sources of water. You wouldn't be all reliant upon one source of water. So, and in the end, it can be a lot cheaper. You know, it's going to be less expensive because there's a, you know, not as high a level of treatment. It's a very high level of treatment, but there are other, you know, portions that you need to add on for DPR that you wouldn't for IPR. But it's definitely a case by case situation, and it depends upon where ultimately the facility is going to be situated and what's the distribution network look like in that area. And like I said, whether there's the presence of anything like a naturally occurring groundwater basin or surface reservoir that's in place already that could use highly purified water from a source like this.
As a follow-up, is there any foreseen possibility that GWRS would convert into direct potable reuse in case of an emergency or future needs?
Yeah, I mean, I never say never. It's not in any of our imminent plans, but in a lot of ways, it would meet a lot of the criteria in DPR. I think in looking at the draft DPR regulations, I think we would have to enhance what we do to a certain extent, but that's possible. I think for us, it's more of if there were some kind of emergency need, the facility is designed and operated very similarly to a DPR facility. So a lot of those requirements could be met with a little modification, but at the end of the day, we are not a water retail agency. So it's not in our district act. It's not what we do. So governance wise, it's probably something we wouldn't do, but the facility has that ability. And we have this very pristine, large groundwater aquifer that, remains sustainable. And that's going to be our goal, is to always maintain that groundwater aquifer as this main source of drinking water for these 2.5 million constituents.
One other question came in for you, Mehul. What happens to the residuals that you produce at GWRS?
Yeah, so there's kind of two main residual streams, and that's always the case with some of these advanced treatment technologies. For our microfiltration, the backwash waste gets recycled back to OC San, and so it goes back to their Plant 1 facility and gets recycled again. The bigger one, which is the concentrate or the brine from the reverse osmosis system, that gets also sent back to OC San, but it gets blended with some other secondary effluent discharges and goes for ocean disposal. So that's always been kind of the biggest issue with reverse osmosis, is finding a timely way to deal with the residual streams. But that's part of this joint agreement, is they take all of our residual streams back, including spent cleaning solution, things that you wouldn't think of, drainage, floor drain waste, everything goes back to them at no charge. And that's been a big reason why the project has been successful and feasible, is that partnership.
For sure. Given the importance of public acceptance, has communication become a policy instrument? And Jennifer or Kevin, you may want to weigh in on that as well. Given the importance of public acceptance, has communication become a policy instrument?
Policy instrument. I'm not 100% sure I understand that. So does that mean communicating the importance of these projects to advance policy? I would say that is absolutely critical. In fact, one of the things we did right after the DPR regulations were passed is Mike Marcus, the general manager of Orange County Water District, came and helped me in the state capitol to talk about the importance of this project and educate legislators and policymakers. As I said, they're tremendous leaders in this area, and communicating the safety has been incredibly critical to get the legislative success that we have. I hope that answers the question.
Kevin, did you want to weigh in there?
Sure, I think I'll take a stab at it and just say that these projects don't happen in a vacuum. And so it's kind of a chicken and an egg question from the way I see it. Is communication a policy tool, or is it something that is required in order to achieve consensus among the people who represent the folks who are paying the bill to make the investment? And ultimately, we're in favor of science and fact-based public policy decisions. And our communities face very, very difficult challenges in hardening their water supplies against all sorts of challenges. So this information is absolutely critical to ensure a healthy public debate and to ensure that communities make the fit for purpose investments that make sense in their communities.
Okay, this next question, Mehul, I'd like for you to start the answer, but Kevin, you may listen carefully to this because there may be some areas you would want to weigh in on. The person asking this question says, my biggest concern is the impurities in the water collected for reuse. Am I swallowing radiation from ocean water? Am I swallowing and bathing in chemicals in the water? Are the ratios of parts per million still at the standards set 50 years ago, et cetera?
I guess I could first start off by saying in a scheme like ours, ocean water is not involved. We're purely taking treated secondary effluent wastewater and purifying it with this advanced technology. Beyond the fact that we have to meet all state and federal drinking water standards, the way the IPR regulations are written and subsequently DPR, there are some standards that go above and beyond even that. So part of the biggest part of this project success is producing water of the highest quality, to the point where we are not worried about merging contaminants, different constituents, because we feel like we've put in place the best available technology, including radioactive byproducts, which we don't see as a major source of contamination in the source water that we treat, but we have the technologies in place to deal with even some of those compounds. So if you just look at the water quality record that we've had over the past 12 years, you can see we've never had any issues with meeting any of those requirements, including those that go above and beyond state and federal drinking water that are specifically part of the current groundwater recharge regulations.
Thanks. Kevin, do you have anything that you wanted to add on regulations, or the regulations keeping up with currently what goes into water and that sort of thing?
I think what I'd like to add is that, to think through this from a kind of a layman's standpoint is to understand that there are regulated contaminants and there are unregulated contaminants. And there are contaminants that we are aware and that we know are in the water. And then there are hundreds of thousands of chemical contaminants or other contaminants we may not even be aware are in the water. So what Mehul said about using multiple barriers and the best available treatment technologies, we know we can attenuate significant portions of the chemical and biological contaminants in wastewater. It's been done successfully for a long time. And what's really important is that if we embark on further and further portable reuse, the work that we're doing around the unknown chemicals and doing that non-targeted sort of analysis, the use of bioanalytical tools and other sorts of methods that are being developed right now will really help us get a earlier start on identifying if there is a problem with some sort of unknown contaminant, but it'll also allow us to adjust the treatment processes and infrastructure investments as the community changes and the character of the influent water changes, which some cases will be like Mehul's where they can have a contract to insure it. Other cases, they may not be able to have quite as much control. So it's an important issue to know that there's a lot of work being done around unregulated contaminants and those unknown unknowns. They're not just being forgotten about.
Okay, thank you. This is a very long question, and Mehul, you're getting a workout today because this is another question that's going to start with you at any rate. Why not take a portion of permeate from BWRO and blend it with the seawater to dilute feed to SWRO to significantly reduce energy consumption below 2 kilowatt hours per M3. I'm not sure what M3 is. Reducing the intake of SWRO by 50% and discharge concentrate below intake salinity. The most important creation of a multi-barrier solution to minimize public concern and reduce the cost of DPR versus IPR.
Okay, so that was a mouthful, but I
know.
The gist of the question is, can you use the product from brackish water RO or a reverse osmosis system like ours that's treating brackish water or reclaimed wastewater and use that permeate to help dilute down a seawater source and then feed that into a reverse osmosis and overall reduce the energy demand in terms of dollars per cubic meter? Yes, that's possible, but at the same time, that would almost in some ways reduce the energy, but you're also treating two separate waters twice. So, I think the key thing here is that, like we talked about at the beginning, is just we have to diversify. So whether you're like us and you're doing what's the equivalent of brackish water RO or wastewater reclamation RO, or you're doing seawater intrusion, They're kind of two separate things. You can combine the two maybe for some of these thermodynamic limits to try to get the energy reduction down. But at the end of the day, that's combining two different sources together and probably will increase overall the operating cost to do that. So I think you kind of have to think of them as distinct sources. There are definitely technological improvements that can be made in something even like reverse osmosis, and something that we're looking at too is ways to bring the cost down, because it really is energy intensive using some of these advanced treatment technologies, whether it's on seawater, brackish water, or secondary effluent wastewater. That's kind of the place that we need to do a little more work on, and that will help also make the technology more readily available to any type of projects that's considering it.
Okay, thank you. This next question, Jennifer, you may have some opinion on this, and Kevin, you may as well. This questioner says, I'd like to know how much transparency will there be regarding information released to the public about the level of carcinogens in the water, as opposed to the information given to the government. Will that information be the same? Will we, the people, be allowed to know that information? You want me to repeat that?
Well, I believe that it will be transparent. I think that agencies that are doing these projects have been models of transparency and will make that information available. And I think that their track record proves that. So I have no, I believe that that will be the case. I'll leave it at that.
Kevin, any observation from you on that one?
No, I think Jennifer's right. These public entities have a track record. It's out there in the open for anybody who's willing to look at it. These utilities have done an incredible job of solving some really, really challenging environmental and human health challenges. It's been done very transparently. It's not easy to get into. I think one of the things that I wanted to say here is that I understand some of the reticence related to information, because even when you look at it sometimes, for someone who's got advanced degrees, it can be difficult to work through. And I think as a community of practitioners, we need to be thinking hard about how we can simplify representations of the quality of water so that people can understand it. And there's work being done on this right now around this identity of water concept. And I think those are really helpful notions for the future. But for right now, I think we have to trust what we can see. And what we see is these utilities are models of excellence and innovation, and take their duty in the public trust very seriously. And I think we ought to be proud of their efforts, because there's no big reward for innovation.
Thank you. I'd like for all three of you maybe to think about this one. The question starts with talking about Orange County, but I think that maybe let's think about potable reuse projects in general that you know of in California. Are there reclaimed water systems in addition to the potable reuse, groundwater recharge, or whatever else the project does? In addition to that, I mean, do people typically have non-potable and potable, or do they do just one of the other?
Well, I believe there's examples in the state where they do both. I believe sanitation districts of Los Angeles County they're embarking on a potable reuse project, and they have extensive non-potable projects. So, I think a lot of communities, I'm just going to go out. I think a lot of communities potentially start with non-potable purple pipe irrigation type projects. That's a way to introduce recycled water into the community. And I think as it advances, I imagine there would be some agencies that would then have that community comfort to advance to a potable reuse facilities. Again, as Kevin kind of indicated, these projects are really big projects. So these are some of the more complex projects than an agency will ever embark upon will be a potable reuse project. So There's so many requirements involved and so many monitoring and other types of requirements involved. You're probably going to see them at first really concentrated in some of the larger agencies. But I would imagine that as the regulations mature and people have a better understanding that you would see more mid-size and smaller agencies being able to adopt that.
Okay. The next question, Mehul, let's start with you, and then Jennifer and Kevin, I'd like for you to address the last part of this question as well. Has the emergence of PFAS concerns and treatment operations changed design considerations of the planned 130 MGD GWRS expansion? And then all of you, please think about what are the most challenging, or what is the most challenging step when it comes to public health protection especially for emerging contaminants like PFAS. So Mehul, how has the PFAS concern and treatment impacted the 130 or the new 30 million gallons a day process? And then for all of you, challenging steps in public health protection with emergent contaminants.
I think luckily for us, it has not affected our last 30 MGD expansion. One of the first things we did when PFAS really came to the forefront and the response limits and notification levels came out in California was to do some extensive testing on the groundwater replenishment system. And, not to our surprise, we knew that we would have a good removal of PFAS compounds. We're using one of the best available technologies, which is reverse osmosis, in addition to possibly granular activated carbon or ion exchange. We knew we had one of the technologies that's proven to remove PFAS compounds. So through that testing on the existing groundwater replenishment system and data that we've seen in other facilities, we know that this is not going to be an issue for us, even with the concentrations we may see in our feed water from OC San. As you know, PFAS compounds or other emerging contaminants are always a large concern, as we said. So we have to just continually enhance the treatment that we have, look at the treatment we have, and ensure ourselves that it's the best available technology. And with what we have, particularly in PFAS, we don't believe that's an issue for the groundwater replenishment system.
Thanks. Jennifer, do you have any thoughts on emergent contaminants and how challenging that step is going to be for utilities?
I think Mehul handled it very well. It is a challenge. And again, we've seen, Orange County Water District has been a leader for us on this area. I think, we're following this very closely. And I think all agencies that have recycled water of all types are watching the PFAS regulations and seeing where that may unfold. And obviously everybody is closely adhering to all the requirements. And so I think I'll just leave it at that.
Okay, I wanted to look at the time here and let you know that we're doing our best to get to all the questions, but in the case that we may not be able to get to all the questions that have been answered, we're mindful of the time of not only our panel, but of everybody else who's on this webinar today. So we will be following up after the webinar, or attendees can email questions to info@ocwd.com, info@ocwd.com. But we have one more question here to pose. This is not for any one person, so see who wants to weigh in. How problematic is stormwater for reuse? What can communities do to make these rare opportunities for large quantities of rainwater runoff a better quality feedstock for reuse? How problematic is stormwater for reuse, and what can communities do to make these rare opportunities for large quantities of rainwater runoff a better quality feedstock for reuse?
Does Orange County want to take that?
Yeah, I guess, you know, part of our operation is not just the groundwater replenishment system. It's part of our operation is to capture as much stormwater as we can in the form of what is collected behind Prado Dam, what makes itself into the Santa Ana River and collected in a series of our percolation ponds. I think the biggest issue with stormwater capture is not so much the quality, which can be an issue because of course it can pick up all kinds of contaminants just from, especially in what we call a first flush or after a storm where there's a bigger potential to pick up contaminants along the way as that water is washed along. The bigger issue is it takes lots and lots of land to truly capture a appreciable amount of stormwater, and land is at a premium in all of California and Southern California, just like Northern California. So it's not very cost effective to be able to capture large amounts of stormwater unless you can have something like we do, which is the Santa Ana River, or a flood control structure like Prado Dam. But you can do little things locally, and there's a lot of cities that are trying to do things locally, like making pervious new developments like parking lots and green fields and parks where they act as almost stormwater capture basins, or they have the ability to be permeable so that water can run off into the local groundwater rather than having such a hardscape that everything just runs off and is lost and not able to be captured. Those are kind of the things that are going into a lot of new developments. But I think most groundwater agencies like ours, or those that operate recharge basins, our main goal is to capture as much of the natural precipitation as we can, given the limited infrastructure we have, because that's the free water, so to speak, and the water that we're not as worried about with contaminants. They're all, even things that it can pick up along the way, the water is pretty pristine. And the fact that it, like for our situation, it can go through a natural soil matrix or an aquifer, that adds additional level of treatment to clean up, that nature do its thing.
Anyone else on that one?
Well, I think I'd just like to add, Patsy, that one of the other elements of the review of Title 22 and the development of uniform water recycling criteria in response to AB 574 is an effort on the regulations related to on-site non-potable reuse. And this is an area where stormwater capture can be done on a cost-effective basis for a specific purpose on a site-specific way. And this is exactly the kind of fit for purpose application that we understand can be done today with stormwater. It's a little challenging, as Mehul pointed out, to build infrastructure that has the capacity to capture these incredible deluges that we receive here, especially in Southern California, so that these kind of site-specific options that Mehul identified, I think that's going to be the first entree there. And then at some point, I think that as you grow and we begin to understand the full water cycle with a little more clarity, I think you'll see additional sorts of environmental and potable reuse that'll come from the stormwater source. I think for now, though, probably going to be on site-specific sort of on-site uses.
Okay, just so everybody knows, we will go ahead and take a few more questions and end by 2:10 p.m. So the panelists have said they're willing to stay for 10 more minutes. So if you do have a question, go ahead and submit it. But here is a question again for any of you to weigh in on. What if a smaller utility than OCWD with fewer resources, technological capabilities, etc., opts for DPR? Could safe operations be guaranteed in the long run on such a case?
So, as I initially said, I think that we're going through the regulations now. They're quite involved. There's a lot of new TMF requirements, plans, and obviously it's going to be a challenge for the smallest agencies. And as I said, I think hopefully as this technology and the regulations mature over time and people have a better understanding exactly what's involved and the cost commitment and staffing requirements, hopefully that can expand out from the very largest, most mature agencies to mid-size. So that's what I'm hoping is the case. But it is a major challenge. And as I said, these are the most complex water projects that exist, probably. Just gonna go out on a limb and say, I think that this is it, so.
Okay, I think you may be right. Kevin, did you want to weigh in?
Well, I just, yeah, a little bit, because I think this is a really important piece of NWRI's work right now, is the, thinking about how do we deploy these technologies in some of the most water stressed and some of the most smallest communities in America. We've done work in New Mexico, in Colorado, and Arizona. This story plays out again and again, where communities don't have the water resources, nor do they have the what we call in California as technical, managerial, and financial capacity to pull these projects through. So we're hopeful that through more experience, additional collaboration, some intelligent application of machine learning and advanced analytics, and some further advances in the technology, I think that that we can deliver these sorts of projects in smaller communities safely. I think there's a lot of work left to do, and I think the concern is wise. But I can tell you that it's a research concern for the Bureau of Reclamation, and we've just received a significant grant from the Bureau of Reclamation to build a human machine interface on a very rudimentary AI system that's running an advanced water treatment plant in Los Angeles County. So we're feeling like there's opportunity here. The AI has shown some promise, and this is the way that we're going to be able to democratize this technology, and in some cases get it where it's needed most badly.
So Patsy, can I add on to
Sure.
one of the big challenges that is going to be a barrier to any community of any size is funding. So that's and we are working. A lot of you know that the governor introduced a drought package, and so did the Senate Pro Tem in California. We have an opportunity this year, because of the budget surplus, to try to direct some of that funding to grants and loans specifically for recycled water. We're hoping we'll have some good announcements in the next couple of weeks as the budget moves forward. We're working very hard on that, because even the largest agencies are going to need low interest loans, are going to need some help make this happen. It's a financial challenge, to put it mildly, as well, to deploy these big and so I'm hoping, like I said, that we'll be able to announce some good news. We're looking we're asking for $750 million in this budget cycle, and asking our members to reach out. So, and I know the national, with the Biden's infrastructure package, is also targeting significant funding as well. So you'll probably get some bothering. Our membership will probably, but without that funding, it really puts these kinds of even the mid-size out of reach, unless we can really get that targeted.
Good point. Thank you. Mehul, this is kind of an interesting question, I think, and might actually have other ramifications, the answer to it. Have there been any measurable changes in water quality of the aquifer receiving GWS recharge water? Has recharge been effective in maintaining the groundwater level, but also what about the quality?
Yeah, we feel like obviously it's been very helpful in maintaining the groundwater levels. It makes up almost 40% of the water that we use to recharge the aquifer. So it's definitely allowed us to keep levels at a sustainable portion, and in meeting with our board policy of having limited overdraft in our groundwater basin. It does over time improve the quality. It does take a very long time because it's a very large aquifer, but it's our hope over time, the fact that we're putting very low salinity water in a groundwater basin that's going up in salinity over time, just because of some of the other natural resources going up in salinity that we use to replenish the aquifer. We will get a dilution effect over time, or at least a localized dilution effect, at least in that respect, to get our total salts down in parts of the basin. It'll take some time, but that's kind of part of the long-term goal of GWS as it becomes a larger component, especially in drought years, of the water we use to replenish the groundwater aquifer. It can only help in that respect in terms of lowering the overall groundwater salinity. Because we do feel like in a lot of ways, the quality of this water exceeds even those of some of those other sources we use. And that's part of why we wanted to invest in this type of system, as opposed to seeking more imported water or trying to find ways to find other water sources that we could procure.
Okay, thanks. This, I think, is for Kevin and Jennifer particularly, although Mehul may have an idea about this as well. How would you see these California-based regulations translating to the national level, given both the infrastructure plans and the varying geologies across the country? How would you, or do you see the California-based regulations for DPR translating to the national level?
Well, I'm going to let Kevin, I'm sure Kevin probably has a better idea on where all the other states are in terms, but I can tell you there's an extreme interest, as California has been the leader in potable reuse in terms of developing statewide regulations. Some states don't want to develop statewide regulations. They're happy with a permit by permit kind of scenario. And we are not that way, because our agencies here want those statewide regulations so they have more certainty. We have great interest in what we're doing. I would also say that California's regulatory regulations are pretty strict, and there's some agencies that don't want to follow our model. And so it's kind of an interesting discussion when we go to our national symposium, and there's different states that have different things that they're working on. So I'm going to kick it to Kevin to maybe you have a better sense of where the other states are in terms of DPR.
Yeah, it's an interesting concept, and the California regulations definitely cast a long shadow over these conversations around the entire world, frankly. So what we do here in California, people pay attention to, and it's influential both in its ability to create a pathway for folks and for them to create their own pathway because they don't like our pathway. And that's, I think that's something I think we all kind of understand intuitively, that that the diversity of our nation is such that when we look at our state and the sorts of natural and built environmental resources that we have, this was going to be an issue that maybe we were going to be a little bit ahead on. But as I look out today across our work, we're doing work in Maryland and in Florida and in Idaho, and places that aren't thought of as places that are water stressed. But I think that that water stress is creating the conversation. California's rules are always going to cast a shadow, but mostly we see states going in a little different direction with a little less prescription. I don't know if that's right or wrong. And I don't think I'm not sure there's even a value conversation to have, because what's important is it reflects the values of the communities that they serve. And I think that's how our governmental system is supposed to work.
Okay, our final question for this webinar. When DPR regulations are due in 2023, what future regulations do any of you anticipate? So with DPR regulations due in 2023, what future regulations do any of you anticipate?
Well, as I mentioned, this DPR package includes both raw water and treated drinking water augmentation. So there's good and some concerns on that approach. But we believe that after treated drinking water augmentation regulations are completed, that we're going to be done with the spectrum of potable reuse regulations for California. That is the spectrum. We still have to do in 2023 the on-site reuse regulations, as Kevin mentioned. We're going to update our non-potable regulations in 2023. That will be complete as well, and the Water Board is working on that. So these are ongoing processes, and the Water Board also will be updating every 5 years. They have a recycled water policy that is basically a mechanism where they look at last time bioassays and additional requirements that potentially could be updating our current regulations and requirements. So I think it's important for the public and others to know that this is constantly being looked at and assessed as part of that process. But treated drinking water augmentation is the end of the line for potable reuse.
Kevin, you want to add to that, or did that cover it?
Well, I think, yeah, I would just add that I think that, yeah, it's the end of the spectrum in terms of the subject matter. I think what we can all look forward to is a little more nuanced understanding of the practical application of the statutes and the regulations as they're written, and then trying to kind of parse that down into guidance and best practices so that these utilities are in a position to produce the best water they can given the circumstances at the time. So yeah, it's I think we're going to move into a guidance phase, and a phase that frankly may be even more influential around the world in terms of how we view the quality of potable reuse water.
Mehul, anything further from you on that?
Yeah, I guess, I mean, I kind of echo what Jennifer said. I think it's just, if anything, as those regulations get more mature and more projects get developed, there's going to be additional enhancement of those regulations. You know, separate from what the state's requiring to take a look at the regulations on some sort of frequent basis, we're going to learn new things, and if anything, we're going to probably add enhancements to the regulation. We've seen that with the IPR regulations compared to when we started versus where they are today. They're going to enhance as we learn things, and probably going to get more strict, and that's okay. And that's something we have to deal with. And then another thing that Kevin kind of talked about was the next frontier. Although there isn't much after potable, the next frontier may be a true on-site system where someone in their own house can have gray water, black water, storm water, all captured on their own property and almost be at a point where they're self-sustained. It could get to that point someday, but that's where regulations would need to be in place, because obviously that's not something that's possible with the current regulations, but that may be where we get to. And that would be something that's beneficial, especially to some of the more rural communities that don't have access to, like we said in the few questions back, to a large project like this, to be able to implement something to meet those DPR regulations that are meant for large facilities, you know, with advanced treatment technologies.
And Patsy, I really think that the research is really going to be critical moving forward. We are going to need that research. We're going to continue it. As I said, there's an alternative clause that it's kind of meant for, we don't know what the state of the play will be in 20 years from now. Nobody knows. So they've built in some flexibility to have some changes there, to be able to demonstrate new technology that meets the requirements that hopefully, you know, that may be useful for folks. So we will always have a place for research moving forward. I believe.
Well, thank you very much for those responses. Thank you to our speakers. Thank you to everybody who attended today. If we didn't get to your question, please send an email to info@ocwd.com, info@ocwd.com, and we'll respond to you directly. A friendly reminder that this webinar was recorded and will be posted on the OCWD website and YouTube page. Thank you very much. Have a great day. Goodbye.